Good afternoon, Algebra 2, Section 6.3. In this unit, we are going to do some math operations in function notation and learn how to compose functions. Example 1, let's add and subtract some functions. If we let f of x equals negative 3x to the 1/3 and g of x equals negative x to the 1/3, we can add, subtract, multiply, and divide them. In part A, let's look at what we do when we add them. So all I'm going to do when I see something in function notation, I'm going to replace their function notation with what it equals. So here I'm going to add these two. What's nice about this is we have the same or like terms, x to the 1/3. So if I have negative 3x to the 1/3 and I want to add a negative 1x to the 1/3, altogether I would have negative 4x's to the 1/3. Easy enough? Let's look at part B. Part B says I want to subtract them. So if I have f of x is negative 3x to the 1/3, I'm going to subtract g of x, which is negative x to the 1/3. Well, since subtracting a negative is adding a positive, and I have these like terms, since they have the same power, I can take negative 3 and add positive 1. This is going to give me negative 2x to the 1/3. That seems pretty easy. Let's look at multiplication and division. Here we're giving two functions, 2x squared and x to the 1/2. Here we want to go ahead and multiply the two functions. So I've gone ahead and replaced function notation, and this is going to reiterate some of our exponent rules. Here I have 2 times 1, which is just going to give me 2. And then if I have two bases that are the same and I multiply them, remember I need to add their powers. So if I'm going to add two numbers and one of these exponents is a fraction, I'm going to make sure that I have common denominators, or think of common denominators. So x squared times x to the 1/2 is the same thing as saying x to the 2 added to 1/2. So 2 with a common denominator is going to be the same as 4 over 2. And 4 over 2 plus 1/2 gives me the same thing as 5/2. And if I could simplify this exponent or simplify this power here, I would do so. But for this purpose, that's as far as I need to go. Let's look at division. F of x divided by g of x. So I have 2x squared divided by x to the 1/2. Well, this would be a coefficient of 1. So 2 divided by 1 gives me 2. If I have the bases are the same, and when I'm dividing, then I can subtract their powers. So this is going to be 2 times x to the 2 minus 1/2. 2, which is the same as 4/2, minus 1/2 is the same as 2 times x to the 3/2. And I cannot simplify this fraction, so I'm going to go ahead and be finished here. Let's look at example 3. Example 3 talks about evaluating composition of functions. So what I'm going to do is, given these three different functions, f of x, g of x, and h of x, I'm going to find the indicated value. Let's look at part A. Part A says we want to find f of g of 1. And just like order of operations, we would perform everything in parentheses first. So I am going to figure out what is g of 1 and take that value and make that f of whatever that is. So let's find out what g of 1 is. G of 1 is going to be 1 squared minus 1. That's not a very good squared. There we go. So g of 1, 1 squared is 1, and 1 minus 1, well, that gives me g of 1 is the same thing as equal to 0. So then I'm going to plug the value for g of 1 in this function composition. So this is going to now be f of, since g of 1 is 0, f of 0. Then I'm going to look at the f of x function and replace the x's with 0. So f of 0 is now equal to 2 times 0 plus 3. And if I evaluate 2 times 0 plus 3, I get 0 plus 3. So f of 0 is equal to 3. Part B. Here we have h of g of 4. So the first thing I'm going to do is find g of 4 by replacing the x in g of x with 4. Okay, so let's do g of 4. So g of 4 is going to be equal to 4 squared minus 1. So 4 squared minus 1 is going to give me 16 minus 1, which is 15. Well, then I need to put that in for the composition and find out what h of 15 is. So if I replace the x with 15, h of 15 is going to be equal to 15 plus 1 all over 5. So 15 plus 1, that gives me 16, and I have a fraction of 16 over 5. So h of 15 is now going to be equal to, well, 5 goes into 16 3 times, with 1 left over out of 5. There is h of 15. Let's go ahead and try one more. H of f of negative 3. So I'm going to find f of negative 3 first by plugging a negative 3 in here for x. So f of negative 3 is going to equal 2 times negative 3 plus 3. This is going to give me negative 6 plus 3. So I can say that f of negative 3 is going to equal negative 3. I can now replace this function notation with negative 3. And then I want to find h of negative 3. H of negative 3, if I look back at what h of x is, that's going to be x plus 1 over 5. So I'm going to replace the x with negative 3, add 1, and put all of that over 5. Therefore, h of negative 3 is now equal to negative 2 over 5. On the other side of your note-taking page, you should have some try these that look like each one of these 3 examples. I would like for you to go ahead and attempt those, and please have your questions ready, and be ready to have them checked.